Hi everyone, welcome you all. In this day 1, I am going to explain circuit elements that is coming under paper 1, unit 1, that is electric circuit. What are the basic circuit elements available in electrical circuit? So circuit element, that is passive elements that is available in the electrical circuit is resistance, inductance and capacitor. Okay, first of all we are going to see what is resistance. It is a property of a material by virtue of which opposes the flow of electron. Resistance restricts the flow of current through the material. It is given by Ohm's law, that is V is equal to I into R. When an electric current flows through any conductor, heat is generated due to collision of free electrons with atoms. So, when a current flowing through a resistor, energy is dissipated in the form of heat. Now we are going to calculate the power. Power equal to the multiplication of voltage into current. Here I have to substitute V is equal to IR. So I into I, that is I square R, and otherwise we can write V square by R also. Next, what is the energy lost in the resistance in the form of heat is W equal to 0 to T P dt, that is equal to, what is the integration of dt, that is T. So P into T equal to, two formula of power is there, one is I square R and another one is P square by R. So one is I square RT and next one is V square by R into T. Next we are going to see Ohm's law. This is a very important law in the electric circuit. This is a basic law also. What is Ohm's law? At constant temperature is very important. The current through any conductor is directly proportional to the potential difference across it. So that is Ohm's law. Next we are going to see the next element, that is inductance. So this is the symbol for inductance. What is inductance? It is a coil form. It stores the energy in magnetic field. The unit of inductance is Henry. A wire of finite length, when twisted into a coil, it becomes the simplest inductor. As soon as the current will flow through a coil, the electromagnetic field is formed. However, with any change in flow or direction of current, the electromagnetic field changes. The change of field induces the voltage across the coil. So VL equal to L into di by dt. So take this equation A. From the equation A, voltage across the inductor would be 0 if the current through it remains constant. Okay, so the constant, differentiation of constant, that will give the value 0. So steady current is flowing, that is constant current when flowing through an inductive coil, we get the voltage equal to 0. Voltage equal to 0 means that's a short circuit. The constant current is DC. So constant DC current, inductor acts as a short circuit. Next, however, for any small change in current direction, inductance will appear. Next, what is the power absorbed by the inductor? The same formula as we used in the resistor. P is equal to V into I. Here you have to put V. V is equal to L into di by dt into I. So Li into di by dt, the unit is watts. Energy absorbed by the inductor. In the resistance only, the energy is dissipated in the form of heat. But in the inductor, the energy stores in a magnetic field. So energy absorbed by the inductor is W equal to 0 to T P dt. So what is the value P? L into I into di by dt. Now both the dt's are get cancelled. So L is a constant, and what is I? Integration of I square by 2. So 1 by 2 into L into I square. So this is the energy of the stored in the inductor. Next, capacitance. Capacitance, two plates are there. One is positive and another one is negative. In between, it stores the voltage. So it is a capability of an element to store electric charge within it. It stores the energy in electric field. What is capacitance? Charge per voltage. So C is equal to charge per voltage. And what is I? I is equal to C into dV by dt. Lowercase letters are represent the instantaneous value. Next, what is the power absorbed by the capacitor? P is equal to V into I. So equal to V into C into dV by dt, because I is equal to C into dV by dt. Energy stored in the capacitor in the similar manner as we done in the inductor, no? So P into dt is V into C into dV by dt. Both the dt can get cancelled and we get V square by 2 half into CV square. From the equation A, what is the equation A? C into dV by dt. We observe that the voltage across the capacitor being constant, current through it is 0. This means capacitor behaves as a open circuit for DC. So I is equal to C into dV by dt. P is constant, so current is 0. The capacitor acts as an open circuit for DC. Next, voltage current relationship of circuit element. First circuit element are, what is the unit? Resistance, RS resistance. Unit of inductance is Henry. Unit of capacitance is Farad. Voltage V is equal to I into R. Here the inductor voltage is L into di by dt. Capacitor I is equal to 1 by C integral I dt plus V naught. V naught is the initial voltage. Current in amperes I is equal to V by R. In inductor I is equal to 1 by L into integral V dt plus I naught. I naught is the initial current. Then capacitor I is equal to C into dV by dt. Power in watts, P is equal to I square R. P is equal to L into I into di by dt. And for a capacitor, C into V into dV by dt. That's all. Thank you. We shall see in the next